Alright guys, so for 4.5 we are going to translate parabolas that are in descriptive form, and then we're also going to be talking about domain and range. So when we're shifting graphs, I have this little chart for you that kind of is a little cheat sheet to help you on what we're doing. If you're shifting your parabola, everything starts at the vertex, so you're always looking at the vertex value. If you are shifting your graph up, that is the y-axis, so you are going to be adding to the y value of the vertex. So shifting up or down is the y value. So if you're shifting down, you subtract. When you're shifting right and left, that is the x value of the vertex. But remember, our descriptive form, or our vertex form of a parabola, is y equals a times x minus h squared plus k. So because our general form in vertex form, that's a minus h, you're going to actually be doing the opposite of what you think is happening. So if you shift your parabola to the right, you need to subtract from the x value, because that negative in the vertex form changes it, makes it the opposite. So when you're shifting left, you're actually going to add. Okay, so the y behaves exactly how we expect it to. When you shift up, you add. When you shift down, you subtract. But the x, because of that x minus h, it's actually behaving the opposite of what you think. So when you're shifting to the right, you subtract, and when you shift to the left, you add. I always find that sketching the graph makes it easier, and then you can find the new vertex and plug it into vertex form to finish. So example 1 says, if y equals x squared plus 6, and it is shifted down 3 units, what is the new equation? So the first thing I would do is I would take that equation, y equals x squared plus 6, and I would rewrite it so that it looks more like vertex form. So remember what we've been doing, guys. This x squared, there's nothing being added or subtracted to it. So how could we rewrite it so that it looks like there is? It would be x plus what?
0.
0. Because it doesn't change the value. So I would first rewrite the original equation as x plus 0 squared plus 6. So let's actually plug this in. This is going to be y equals, and then I'm going to do plus 0 and leave a blank, squared, plus 6, and let's alter it based on what we have. So we are shifting down 3 units. Which number, 0 or 6, has to do with the y-axis shifting up or down? 6. So the problem tells us that we are shifting down 3 units. Is shifting down the y coordinate or the x coordinate? The y. So we're really only looking at the 6 here. So according to my chart, when I shift down, remember, y's behave the way we expect them to. So you're going to subtract from the y value. So we're shifting down 3, so we're going to subtract 3 from y. And then that's all we're doing is shifting down. So we have nothing else. So we're going to simplify, and that's going to be our new equation. Y equals x plus 0 squared is just going to give me x squared. 6 minus 3 is plus 3. We can test this by graphing. So I'm going to do just a quick check of my answer by graphing. If you look at our original equation, my vertex is 0, 6. So let's graph that. 1, 2, 3, 4, 5, 6. So my original vertex looked like that. What's my new vertex? 0, 3. So let's graph that. 1, 2, 3. How did that graph shift It's pretty messy, but that's okay. It went down 3, right? So the graph went down 3, which is what we wanted to do. Okay, so we did get the answer correct. So example 2, we have if y minus 3 equals 2 times x plus 5 squared, and it is shifted 3 units. What's to the left? What is the new equation? This one also doesn't look like the way we're used to. What can we do to get it to look like what we're used to seeing? Yeah, you can just add 3 to both sides. So I'm going to rewrite this as y equals 2 times x plus 5, and I'm going to leave a blank squared, plus 3, and leave a blank behind that. So we just moved that 3 to the other side so that we have y equals, because those cancel. So then let's fill in the blanks. I'm shifting to the left 3 units. That is the x-coordinate. Left is with the x, so when we're shifting to the left, remember, x does not behave the way we want it to. So will I be adding 3 or will I be subtracting 3? Adding 3, and we add it inside the parentheses because that's where the x-coordinate of the vertex is. So you add it to whichever coordinate it is that you're shifting. So we simplify. That's going to give me y equals 2 times x plus 8 squared plus 3. So the only thing that we're really changing is the x and the y coordinates. And in this case, all we did was shift to the left, so it didn't affect the y at all. So if we were to check our answer with the graph, my original vertex was -5, 3. So that would be 1, 2, 3, 4, 5, 1, 2, 3. Up here, and it was opened up because you take the opposite. So the vertex, our new vertex for the new equation would be -8, +3, because you have to take the opposite of that x. So if we were to graph that, I come off of the graph, but it would be somewhere over here. And if you look at the new graph, this is messy, I'm sorry, it shifted to the left 3. So you can graph a sketch of it and count how much it shifted to double check that your equation is correct. Okay? Okay, so example 3, I give you the graph x squared, and we are shifting it 3 units to the right only. So we're not shifting both. I was just kidding. How can I rewrite y equals x squared so that it's in vertex form, so that it looks like it's in vertex form? X plus 0 squared, and then the y is plus what? 0. So I'm just putting those as placeholders so that I know what I'm missing and what numbers are actually there. So let me rewrite this with spaces so that we can actually do our work. So this would be x plus 0 space squared plus 0. So looking at this, I am shifting 3 units to the right. Is shifting to the right affecting the x-coordinate or the y-coordinate? The x. So we're looking inside the parentheses, but everything inside the parentheses is opposite of what we think is going to happen. So when I'm shifting to the right, does that mean I'll be adding or subtracting? Subtracting 3. And then we didn't shift up and down at all, so we can ignore that y. So let's rewrite this as y equals x minus 3 squared. And then we don't have to put the plus 0, so that's your answer. So the vertex of the new one would be +3, 0. So example 4, we have y minus 3 equals 1/3 times x plus 2 squared. We are shifting 4 units down and 3 units to the right. So first thing we need to do is get this in vertex form. So you're going to add 3 to both sides. And then I'm going to put in my blanks as well. So this is going to be y equals 1/3 times x plus 2 leave the blank, squared, plus 3. And then let's look at how we're shifting. I am shifting 4 units down. Units 4 down. That doesn't make sense. 4 units down. So if I'm shifting down, is that the y or the x? The y. And since it's the y, it behaves the way we expect it to, so we're going to subtract 4 from y. I'm also shifting 3 units to the right. So shifting to the right, for you guys, that's this way. So you're going to subtract 3 from the x. Good. And then simplify and you're done. So this is y equals 1/3 times x minus 1 squared minus 1. You will see problems where they give you the original equation and the new equation, and you have to tell how it's been shifted, so you just go backwards from what we've been doing. When I see those types of problems, typically I graph them, and then I just count the spaces. So you know how we were doing to check our work on the first 2 examples? If you are given the original and the new equation, I graph both and then just count the spaces to see how it shifted. So it's the exact same thing, but backwards. Okay? Okay, so domain and range, guys. Domain is the set of all x values that the graph covers. Okay? So domain is all x's that the graph covers. Range is the y's that the graph covers. Okay? So domain is x's, range is y's. So what we're going to be doing, I'm going to give you 3 graphs, and we are going to be finding the domain and range for each of those just based on the graph. Okay. So example 5, I'm giving you y equals 3 times x plus 2 squared minus 5. I just want a sketch of this so that we can see what's going on. What is the vertex of this parabola? -2, -5. So graph that, -2, -5. So it should be here. And then, so the important part is the vertex and if it's opening up and down. Is this one opening up or down? Up. So I just want a quick sketch of the vertex and it opening up. I don't care about width or anything because we're just using it to help us find the domain and range. Okay. Okay, so domain. Domain is always the tricky one because it has to do with our x's and our graph always grows on forever and ever and ever. So take a look at our parabola. Does the parabola always continue to grow wider or does it ever stop and just stay the same width? It continues to grow wider and wider and wider and wider however far out we go, right? So all the x's on the x-axis are covered by that graph that grows forever and ever, and it continues to get wider. So we say that our domain is all real numbers, or you can use the symbol for all real numbers.
Will it always be real numbers?
It will always be all real numbers because it's always growing out. So it has to do with what x's can I use to graph this. You can plug in any x you want, and you'll always get an answer. The only time it wouldn't would be if your parabola was opening, no, sideways. Because all these x's back here aren't covered, right? But they are covered going this way. So, as long as your parabola is opening up or down, you are covering all the x's. Now the y's are a little bit different. What do you notice about this parabola in terms of the y's? Does it have a minimum or a maximum? It has a minimum at what? Y equals -5. Are there any y's that are less than -5? Are any of these y's covered in the parabola? No. So all of our y's have to be greater than or equal to -5. Negative 5 is the smallest y, and then it continues to grow up. So any y that's bigger or equal to negative 5 is part of the graph, but everything below is not. Does that make sense? So you're looking at what is covered by the graph and what is not covered by the graph. Okay? I think that's probably good. There will be problems where the graph is given to you in standard form, not vertex form. So in order to graph, you'll have to actually do the x equals negative b over 2a and find the vertex from there. Okay?